Math Marvels. We're going to talk about right triangles. I love this type of math. This is when I felt like I was doing real adult math as a kid. And we're going to talk about the relationship between the sides and angles. We're using a very special formula called the Pythagorean theorem. But before that, we got to talk a little bit about right triangles, and I used this site just to get this nice little image. Now, a right triangle is a very special triangle. And it's special because it has a right angle, it has a perfect 90-degree angle. And there's so much math connected to this that you're going to do a lot when you're in high school. So other vocab words, because we're going to need these terms, we're going to use the term hypotenuse, and that is the longest side. It's the longest one, and it's the longest one because it is opposite of the longest angle. In this case, it's a 90-degree angle. The two other angles in a triangle are going to be less than 90 degrees each. Two acute angles, which means that both the legs are going to be smaller. And we're going to use a certain formula to figure out the size. So there's this really special relationship. A squared plus B squared is equal to C squared. In other words, the length of one leg squared plus another leg squared will give you the longest leg squared. So these two are going to be the legs, and this is our H, our hypotenuse. I'm just going to put an H there. I'm going to leave my calculator here on the side because you're going to see how we're going to use this formula. And to find a side, we're going to have to do some square roots. So I'm going to show you doing some modeling, and please just watch what I'm doing. In the beginning, you're going to feel like you're just imitating, and you may think, I don't understand why this works. That's okay. Again, go back to my YouTube channel. I'm going to post a video that actually shows you why this formula really does work. We have a right triangle. It's just turned over on its side. I can tell it's a right triangle because it has a 90-degree angle. It has that little square in there. And that means that the opposite side, the one that's right across from it, this is our hypotenuse. I'm just going to put hypo. Okay, that's our longest leg, our longest side, and that means these other two are the short ones. This is a leg and this is a leg. So I'm going to use this formula, A squared plus B squared equals C squared, to find out any of the sides of a right triangle. As long as I have two sides, I can figure out the other one. So looking at this one, I know that my two short sides are 10 and 24. So I'm going to put that in there. 10 squared plus 24 squared. I'm using my little legs are my A and B, the short sides. And my biggest side, my hypotenuse, is just C squared. I'm just very used to writing the C squareds for now. So to solve this out, we're going to start by simplifying the expression that we see here. And we have a lot of things with exponents. So 10 squared, we're going to solve that part first. 10 squared, let's simplify this. That's the same as 10 times 10. That is 100. 24 squared, if you're not sure, just use your calculator. And that's 576 is equal to C squared. So now I'm just going to add those two together. 100 plus 576, that's 676 is equal to C squared. So again, I'm going to undo this now. I want my C by itself. That means I need to find the square root of both expressions. So again, I'm using my calculator to find the square root of 676, and I get 26. This means that my longest side is equal to 26. So I'm putting in my equation, A squared plus B squared equals C squared, and you can follow my work to see how, from my formula, here's my formula, here's my substitutions, and then I start solving the problems to simplify it. Hit pause so you can jot this down into your notes. And again, you can just see how my calculator is just a tool. All my thinking is still on the page, but I can actually work through the problem this way. All right, in this problem, we're going to try to persuade Mr. Lisa whether the numbers 5, 12, and 13 make a right triangle or not. So are they a Pythagorean triplet? Do they actually work together to satisfy the Pythagorean theorem that we just learned about? And we're going to show our work. So that's the first question. We just want to know, is this a right triangle? And using that theorem, can we prove it's a right triangle? So it's not just is it, can we prove it? We know the side lengths, and we also know this is a right triangle. And because of that information, we know we can use the theorem that we just talked about. We're going to sub in the values for A, B, and C. And then we're going to evaluate it and see if the sum of A squared and B squared is equal to C squared. Hit pause so you can jot this down into your notes. Let's put our plan into action. I just made a little visual so we can see all the sides of our triangle, and we're going to see whether or not this is true using our theorem. A squared plus B squared equals C squared. I'm going to use my short sides, the 5 and the 12. And some people ask me, how do you know which is the A and which is the B? Doesn't matter. Being honest with you, Math Marvels, the A and the B are just the short legs. So it doesn't matter. This could be A, this could be A. I just know that the expression has the two short legs squared. And the longest is going to be on the other side. So 13 is my longest side squared. And now I'm just going to evaluate this to see if it's true. Okay, so let's do evaluation. 5 squared, I can do in my head, is 25. 12 squared, so 12 times 12 is 144. And 13 squared is 169. Now, you do have your calculator, so if you're not sure, you can always just use this to figure it out and use this as a tool. That's what a calculator is, just a tool. And you can see all my numbers are accurate. Now I have to do my last step. Let's start simplifying the expression on the left. 25 plus 144 is 169. So 169 is equal to 169. So this is a true statement. So yes, a 5, 12, 13 triangle, a right triangle. I proved it using the Pythagorean theorem. And boom, that's it for right now, Math Marvels. Let's hit pause so you can jot this one down into your notes. And this is what you're going to do. You're going to do these types of problems today. You're going to use Pythagorean theorem to either find the missing side or to prove whether or not you actually have a right triangle. This is a lot of fun. I love these types of problems. So just try them out. We're going to get lots of practice in future lessons. So I will see you in the next lesson, Math Marvels. Take care.